Okay, so we're getting into number Unit 7, Section 5, and this is actually using trig ratios so that we can find stuff. We've been doing this a lot already, but we're going to focus a little bit more on actually using these ratios to our benefit to find unknowns. This is a little bit more focus on that directly. So we have arc introducing arc sine, arc cosine, and arc tangent a little bit more directly in this lesson, and then sine, cosine, and tangent just going over that, and more directly and with purpose, saying if we're given two of any of the four things that we can be given of a triangle, theta, and then one of the sides or two of the sides, we can find anything else about a right triangle, right? So let's just go ahead and start here, and we're gonna again color code our stuff, our z. This the z here is orange like it has been this entire theme here. Our theta, relative to theta, our opposite or our y, our up and down. Up and down, I like to call it y. This could have been b if it was you're using other format. Our y values are burgundy, and our x values are green, and carrying forward the theme. So, and these are our adjacent. X is green. Okay, so if you remember, our sine is opposite, opposite. I need to over adjacent. Okay, opposite over, sorry, hypotenuse. Hypotenuse, or y over z. Okay, and remember cosine. If you guys can think of what cosine is, remember it's adjacent over, which is x, over hypotenuse, which is x over z. And then our tangent here is, remember, opposite or our y over our adjacent, j over, which is x. That's just be a review for you. Okay, so if we were to solve these, kind of get rid of or ignore the that doesn't really help me ignore it, but maybe that helps. So if we were going to ignore sine theta and solve for theta, right, we would just say that and this is called the arc sine, right? So if we were to wanted to solve for theta and just kind of move theta over there and algebraically shift it around, the arc sine of theta would be equal to y over z, right? We just took this and then we just swapped theta, and we just swapped the ratio for theta. Okay, so it's not like we took the ratio and flipped it and moved it over. We just swapped the two around, right? So that is the arc sine of theta. The cosine would be x over z. X over z, and the tangent would be y over x. Opposite over adjacent. Right, so say I had, let's say that I had So you'll see how this works. All right, let's say for instance I had theta, for example, say theta is 37 degrees. Say for instance 37 degrees. Okay, and we'll say that x is 5. Okay, so if x was 5, 37 degrees, the sine, or that would be the cosine of theta, right? Then, okay, so then you know that we're using cosine of theta, you know that the hypotenuse has to be longer. So I'm going to invert that to make that longer. Multiply that by 5. This would be 6.26, right? So that means if I were to redo that, 5 divided by 6.26 equals that. Now I would figure out the inverse cosine of that, and that would be 36 degrees, right? There's a little bit of rounding errors there, right? So that you can see that kind of how that whole thing works, right? So if I wanted to figure out what the sine was, right, it would be 37 sine, right? And then, 37 cosine, right? And then I have to invert that. Well, actually, I want to do. Let's see. I have the hypotenuse now, right? So I want to go 37 sine. Okay, so I know that this, and then it's gonna be, so then I'll multiply this by 6.26. So this will be 3.76. All right, so if I go 3.76 divided by 6.26 equals, that's about that, and I'll do the inverse sine. You can see that's about 37 degrees. All right, so that's how you kind of use these arc sines and sines to figure out all the pieces parts of that. So let's now see if we're given theta, right? If we're given theta and we have x. So if we're given theta and we have x, how do we figure out y? Well, so let's see. We're given theta and we're given x. So we can do this a couple different ways, right? So we can say the tangent is opposite over adjacent, right? We can use tangent of theta equals opposite y over x, right? And then we can solve for y. So it would be y equals the arctangent of theta multiplied by x times x, right? So that's one of the things. So that's one of the ways that you could do it. Another ways you could figure out y is you could use cosine. It could be y equals inverse cosine of theta times x, right? Just because cosine is opposite over hypotenuse, well, we don't have the hypotenuse, so that wouldn't work. All we have is x. Trying to figure out y. So that's what we would work. If we don't have, we're trying to figure out y. The only thing that has x in it and y in it is tangent. So we'd work out that one. So for this one, we have to use cosine, right? So the cosine of theta, equals x over z. This should be green. Equals x, the cosine of theta equals x adjacent over hypotenuse. Over hypotenuse. Right, so to solve for z is going to be equal to the inverse cosine, or the arc cosine of theta times x. Okay, so that's how we'd figure that out. Clean this up a little bit. I'm going to use purple for tangent because it's kind of both of them. So tangent of theta equals y over x. So rearrange equations to solve for y. Y equals the arctangent of theta multiply times x. Okay, so that is how you'd figure that one out. Okay, now the next one I'm given is x, and I'm trying to figure out x and z. Okay, I'm given theta, and I'm given y. Okay, so how do I figure out x and z if I'm given the other two things? All right, so again, if I'm trying to figure out x because I'm given everything else, right? Or I'm just given x and z, right? What function has theta and y in it, right? So I can use sine, or I can use okay, well, this has theta and y in it, right? It has y, it has my variable I'm trying to find, and it has theta, right? Because tangent is just a function, right? So I would use tangent of theta equals y, which is given to me. It would be a given, divided by x divided by x. Rearrange my equation. X equals okay, multiply both sides by that, and then so x would equal y divided by the arctangent divided by the arctangent I don't know how I wrote arctangent. arctangent of theta. Okay? And so over here, we're trying to figure out x. We're trying to figure out z if I know x. Right? So if I try to figure out z and I know x, then again I can figure out or I know y. I'm sorry, I know y. Then I'm going to be using sine. Right? Sine of theta equals y divided by z. Okay? And z is what I'm trying to find. Okay, so z is going to be equal to the arc sine of theta times y. Okay? This is very similar to that. Okay? So now if I'm given theta and I'm given the hypotenuse z, right? These are the two things I'm given. How do I figure out x? Well, I'm given z, so I'm using sine and cosine for these ones. Okay? So if I'm figuring out x is my unknown, right? So I'm going to be using cosine. All right, so cosine of theta equals x over z. So x equals the arc cosine of theta times z. And then y is going to be very similar for sine, except for y. The sine theta equals y over z. So y equals sine theta times z. Okay? Alright, so that's all how I figure out all that stuff. And it's just, if you know these, you don't have to memorize these, right? You don't have to memorize this stuff. I don't want you to memorize this stuff. I want you to know these, right? And you should be able to know these just by knowing these, right? You can derive the rest of this stuff with algebra, okay? I just want you to see these relationships, okay? Don't memorize this stuff. Just know how to do algebra. Okay? It's simple algebra. If you need help in doing the simple algebra, I'll help you with it, okay? Don't memorize this stuff. You'll lose your mind trying to memorize this stuff. Okay. But, so x and y here. If I'm given x and y, how do I figure out theta and z? Okay. So, if I'm given x and y, how do I figure out theta? Right? So, let's see. Alright, so if I'm given x and y, well, what is x and y? Well, that's the tangent, right? So if I'm given x and y, I can figure out that the tangent the arctangent of, that should be purple, the arctangent of might not be using arctangent. The arctangent of x, y divided by x equals theta. Right? So if I do y divided by x, that arctangent, that's the definition of arctangent. Okay? So what is z? Well, if I want to figure out z, I have the arctangent. I can use sine or cosine. Right? And I can say the sine arc sine of y over z equals theta, once I figure out theta, right? And then I can say, therefore, z equals sine, arc sine of theta times y. Or if I did the cosine, it's the same math. It would be z equals the arc cosine of theta times x, right? It's the same stuff, right? It's either one of these if I know theta, right? It's either one of these, okay? If I know x and z, right? If I know x and z, it's going to be the arc cosine, right? So the arc cosine of x over z equals theta. Okay, that's the definition of arc cosine. That's how I figure out what theta is. Right? If I want to figure out what y is, knowing that, right? And once I figure out what theta is, I can say I'm now going to figure out what y is, because sine goes with y, right? Sine, the arc sine of y over z equals theta. So sine theta times z equals y. Okay, just algebra. Okay, and then finally we have, if I'm given y and z, I'm gonna figure out theta, right? That means I know x, right? So I'm going to use, let's see, that means I know y, right? That means I'm going to use the arc sine. The arc sine, which is y over z equals theta. Sure, equals theta. Okay, now once I know theta, I can figure out x, right, by using cosine, right? Arc cosine. So the arc cosine of theta equals x over z equals theta. So z equals the cosine theta times x. Okay, so that's how all that works out. Let me show you a few examples, and I'll let you guys, I won't take them all, but I'll let you guys do the rest, okay? So here, again, there are the topical guide adjectives. Use trigonometric ratios to find sides or angles of a right triangle. You're only given two of of everything. Well, of course you know they're right triangles, but then you're given, you know, two of the components, and then you can find everything else. Okay, so this is my x. This is my opposite. This is my y. This is my x, and this is my z, right? And then this is my theta. Alright, so if I want to figure out what this angle is, this is pretty obvious what that angle is, right? If you don't know, it's 90 minus 43, right? That's 47. That's 47, right? Because these two angles have to make up 90, because the third angle is 90. Right, 9 plus 9 is 180, so that's 47, right? So, but that's right. I'm trying to figure out x here. Okay, so x, I could use this one as this is opposite in reference to theta, my orange theta. Theta equals 43 degrees. Okay, I need to figure out x and z. I'm going to figure out x equals, and z equals. Let's figure out both of those. Okay, so in order to find x, what function could I use? Right, the only value that I have is the opposite. Right, so what function involves adjacent coupled with opposite? That would be tangent. Okay, so arctangent equals theta, 43 degrees, right? The arctangent, opposite over adjacent, equals 8 over x. Okay, so the arctangent of 8 over 3 equals 8 over x equals 43. All right, so 43 times the the arctangent. Sorry about that. The arctangent of 43 equals x, but we have this 8 left over, so 8, right? So it's 8 times the arctangent of 8, the arctangent of 43 times 8 equals x, right? Because this is a fraction, right? So this is the arctangent of theta times 8 equals x. Okay, so that's how we rearrange that to make it equal, to figure out what this x equals. All right, so if we go 43 arctangent, okay, that means that this side is 88% long as this side. Okay, it's the ratio. Wait a minute. 43 arctangent, okay. And then, wait a minute. Oh, sorry, 43 tangent. Should be tangent of 43. Sorry about that. Tangent of 43. This is 93% of this is 93% length of that. Okay, and then we're going to multiply that by 8. So this length, x is 7.460. Okay, 3 decimal places. All right, so we're going to check our work here to make sure it makes sense. So opposite over adjacent, right? 8 divided by 7.460 equals that. And we're going to take the inverse arctangent of that, and it's 40 opposite over adjacent. That's 47 degrees. That's adjacent over opposite. I don't think I did that right. think I did the, let me double check that math there. A long video, sorry about that. I think I may have done the reciprocal. Okay, let me do that again. All right, so the arc, so the tangent of 43 degrees equals 8 opposite 8 over x. Okay, so that is the way you would set that up. I don't think that's the way I set it up before. Okay, so in order to find out x, I would have to solve. I would say x equals 8. That's the problem that I did before. 8 divided by the tangent of 43. Yeah, that's where I made the mistake. Okay, so 8 divided by 43 tangent equals, this is 8.5, should be green. This should be 8.579. All right, now let's check that. Equals 8.579. All right, that's better. Okay, so I set that up right that time. Sorry about the confusion. Ignore that first part. Okay, so now we'll check that. So if I opposite over adjacent, 8 divided by 8.579, and then I'll take the arctangent of that, and now you have 43 degrees. All right, so always check your work, right? So I had the reciprocal of that, so this is why I had that as 43 degrees and not 47 degrees. So always check your work. That's how you know you did it correctly. Okay, so that checked. So now how do I figure out the z value here? All right, so what function could I have that would have referencing theta here, that would have this or this, and figure out my z value. I like opposite over hypotenuse, right? So because it has fewer rounded numbers, that's a full number, so I like opposite over hypotenuse. It's a sine. The sine of 43 degrees equals 8 over z. Okay, so now solving for z. Z equals 8 divided by sine 43. Okay, so now we're going to just say sine 43, 8 divided by 43 sine equals, and that means that z equals 11.73. 11.73. Okay, so double check our work here. We'll double check it using cosine. All right, so cosine is opposite over hypotenuse, or sorry, adjacent over hypotenuse. So 8.579 divided by 11.73 equals, and we'll do inverse cosine, and that's 43 degrees, so we know that that's checked right. Okay, so that's how you do that kind of stuff. Let me double check this stuff here and make sure it makes sense. And it looks like I did that stuff correctly over here. My algebra makes sense over there, because over here I was given theta and y. So theta, I was given theta and y. Yeah. Okay. Z, well, this should be z is divided by y. Oops. Divided by y. All right. I did that one right, though. Okay. All right. So I hope everything makes sense to everybody. Maybe some more algebra errors in here, but hopefully not. When rubber hits the road, common sense prevails, right? Double check your work. That your hypotenuse should be your longest leg, right? And your 47, your biggest of the two angles, the opposite one should have the longer leg if it has the biggest angle, aside from your 90-degree angle. The two acute angles the bigger of the two acute angles should have the opposite leg be bigger, right? So those are some dummy checks to make sure that you're doing your ratios and stuff right. Okay, so I hope that made sense to everybody. If you see any algebra errors on here, let me know, please, so that I can go through and rectify anything that I did wrong, because it is 10 o'clock on Christmas, so I may have made a mistake. Hope you guys have a wonderful rest of the day.